Okay, so yeah, I'm gonna be working on the advent of code, and I'm gonna start with problem one and see how much we can do in not an hour now, but 45 minutes, because the plumber is coming at 5 p.m. and I need to fix my shower. So the whole idea of doing advent of code is actually from Cbro right there on the chat. Hi Cbro. So Chris Broadfoot, we used to work together at Google, and he was doing that today in his own channel, which by the way I recommend. So go check it out too. And I saw it was kind of fun. So and Franziska, that's her name. Which it's amazing that I will forget a name which is Franziska. Pretty easy to remember for me should be. But anyway, we're gonna be starting from the first problem. So as you can see here, there's a bunch of different problems. It goes from 1 to 25 because that's from the first day of December to the 25th, which is Christmas. And basically the idea is that instead of eating a piece of chocolate every day, instead you avoid diabetes, and instead of getting diabetes, you just learn how to code better. So that's what we're gonna be doing today, and we're gonna start with number one. So let's see. So number one, what does it say? Let's read this. We've detected some temporal anomalies. One of Santa's elves at the Temporal Anomaly Research and Detection Instrument Station, which, by the way, that spells TARDIS, which is kind of fun, tells you she sounded pretty worried when she called you down there. At 500-year intervals into the past, someone has been changing Santa's history. The good news is that the changes won't propagate to our time stream for another 25 days, and we have a device. She attaches something to your wrist that will let you fix the changes with no such propagation delay. It's configured to send you 500 years farther into the past every few days. That was the best we could do on such short notice. The bad news is that we're detecting roughly 50 anomalies throughout time. The device will indicate fixed anomalies with stars. Oh, so this is actually the intro to the whole thing. Okay, so 50 problems because it's going to be 2 per day. It's 25 days. So yeah, the device will indicate fixed anomalies with stars. The other bad news is that we only have one device and you're the best person for the job. Good luck. She taps a button on the device and you suddenly feel like you're falling. To save Christmas, you need to get all 50 stars by December 25th. Collect stars by solving puzzles. 2 puzzles will be made available on each day in the advent calendar. The second puzzle is unlocked when you complete the first. Each puzzle grants 1 star. Good luck. After feeling like you've been falling for a few minutes, you look at the device's tiny screen. Error. Device must be calibrated before first use. Frequency drift detected. Cannot maintain destination lock. Below the message that the device shows a sequence of changes in frequency, your puzzle input. A value like +6 means the currency frequency increases by 6. A value like -3 means that the current frequency decreases by 3. Okay. For example, the device displays frequency that changes of +1, -2, +3, +1. Then, starting from a frequency of 0, the following changes would occur. Current frequency 0, change +1, resulting frequency 1. Current frequency 1, change of -2. Then it goes to -1, and -1 plus 3 is 2, and 2 plus 1 is 3. In this example, the resulting frequency is 3. Here are other examples. So 1, 1, 1 is 3, 1, 1 minus 2 is 0. Okay, so that seems pretty easy. So let's do it quite quick. So I'm gonna open my digital terminal right here. And I'm gonna go to, I'm actually gonna create a new repo. Advent of code 2018. Git init. And let's do 1, 1, 1. Actually, does this have a name? Oh, wait, TARDIS has... Hover your mouse over the TARDIS. Where is the TARDIS? TARDIS. Oh, this. This? Or there's a TARDIS somewhere. Okay, Eric, I think either he's messing with me or I don't see no TARDIS. Just pause your mouse here. Okay. Oh, wow. It's about as big on the inside as you expected. Wow. Cool. So let's code. Let's do. Okay, so this one doesn't really have a name, so I'm gonna do day one, problem one, and since we're gonna go up to 25, I'm gonna do 0, 1, 0, 1. D1, B1. That goes also. So D1, B1, and let's write some code. Okay, so we're gonna need to solve the problem given this. So I'm gonna do curl of that, and now we're gonna have, please log in. Oh, really? Okay, so let's do save link as, and we're gonna do it under Francesc. What? Oh my god. Source, GitHub, Campoy, Advent of Code, D1, there you go. Okay, so we have the input, which is just a series of numbers. So what we need to do is just simply read them and sum them, I guess. So let's write a new program. And is this big enough? Like, can you see this code? No one's answering, so I'm gonna assume it's yes. Or there's a huge. Okay, cool. Apparently, there's a huge time in between, a huge lag in between what I say and you hear it. So cool. Okay, so we're gonna open that file. So we're gonna do os open of input dot text. If the error is not nil, we're gonna log fatal R, otherwise defer F close. Then we're gonna be reading line by line. So I'm gonna be using buff.io, the new scanner of F. So it's gonna be the scanner, and the way to use it is for s.scan something something, and if error is not, if error equals that and error is not nil, then log fatal error. In between, what we're gonna be doing is we're gonna do an ss-scan f of a number. It's a float. Is a float or it's an integer? Okay, so let's do an integer, and let's do the number, which is gonna be an integer. And then we're gonna read this. This returns an error, if not mistaken, and an error. Oh, that needs to be a pointer, so we can modify it. What are you complaining about? Can I use stat? Oh, ss-scanf. Oh, because that is, we're reading from s.text. Then we're reading that. That returns a number and an error, and if that fails, we should also log fatal f could not read this because of this. So that's gonna be s.text and error. And then let's see what else. We're gonna have a sum. So actually, sum equals 0. Sum plus equals n, and print n. Now print sum. Alright, this looks pretty decent, like pretty straightforward. Go run main.go, 520. 120. Yay! 1 gold star. Cool. Okay, so that was pretty straightforward. So let's do part 2. So let's create day 01, part 2. And actually, let's do code in here and close this one. Okay. Okay, so you notice that the device repeats the same frequency change list over and over. To calibrate the device, you need to find the first frequency it reaches. To calibrate the device, you need to find the first frequency it reaches twice. For example, using the same list of changes above, the device will loop as follows. Current frequency is 0, change of +1, resulting in frequency 1, then from 1 minus 2 goes -1, -1 plus 3 goes to 2, 2 plus 1 goes to 3. At this point, the device continues from the start of the list. Oh, +1, -2. Okay, current frequency. So these repeats, +1, -2, +3, +1, current frequency, resulting frequency, which has already been seen. In this example, the first frequency reached twice is 2. Note that your device might need to repeat its list of frequency changes many times before a duplicate frequency is found, and that duplicate might be found while in the middle of processing the list. Okay, so they give you only 4 of these because that's a loop, and then you need to figure out when you repeat the same frequency twice. Git add and commit part 1. Okay, you actually are. I think that's a good idea, indeed. Git add day 1 p1. Part 1 day 1 part 1. Cool. I'll create the repo and push later though. Okay, so here are the examples. First, so you always start by 0. So -1. So +1 -1 that you need to return 0. +3 +3 +4 -4 first. Okay, cool. So let's download the puzzle input. I just gotta do it like this. I'm lazy enough. Okay, so that looks pretty good. Cool. So what is the first frequency that your device reaches twice? Yeah, that's what I just did. Okay, so wait, isn't that what I just did? Input.text. There you go. And let's create a main.go. And I guess I can be pretty lazy and just copy. So part 1 main.go, and just gonna start from there. Let's see. So what we're gonna do is we're gonna be reading the file and we're gonna doing all of this, but instead of checking the sum, we're also gonna be having a scene, which is a map of integers to booleans, and scene is a map of integer to booleans with 0 set through, and then every single time we get this, we're gonna do if scene of sum, then print sum and return. Otherwise, we're gonna do print of we're gonna say scene of sum equals true, and that's it. I think that's pretty much it. So let's see what. Alright, so go run main.go. Interesting. That didn't return anything. So let's see. Let's try with something easier. So +1 -1 -1. So I returned 0. That's good. Let's get the examples from here. So +3 +3. Okay, that says, okay, so that doesn't work. So let's see. Let's print the sum that we're reaching. So 3, 6, 10, 8, 4. Oh, because we need to loop over this many times, right? That's the thing. We might need to loop extra times. So it's not only for scan, but actually we're gonna have to create, so I'm just gonna create the numbers first. So let's do this. Nums is a bunch of integers, and we're gonna scan the number and say nums equals append nums of n. And then in a second step, we're gonna do forever for n range in nums var sum. So sum equals 0, scene equals map of int to bool with 0 set to true already. And so sum plus equals n, and if scene of sum, then print sum and return. Otherwise, scene of sum equals true. All right. So 10. Is that what we expected? Yay! All right, let's see this one. Let's try a couple ones and then see whether this works or not. So that says 5. Cool. And just one more. And this says 14. 14. No main test.go. This is main test.go. I'm running things. Okay, so let's do the puzzle input. Put it right there. Run the thing. 394. And 394 is correct. Yay. Okay, cool. So, interesting. We got something. No idea what that is. Okay, so let's go back here. Git status, git add. Oh, not here. That's why. Git status, git add, git status, git commit -m. Day 1, part 2. Cool. And let's create day 2, part 1 already. And code in there. You need some Git aliases. No, I like to write all of my things one by one. I'm special like that. Okay, so day 2. Inventory management system. You stop falling through time, catch your breath, and check the screen on the device. Destination reached. Current year 1518. Current location North Pole Utility, closet 83 and 10. Okay, you made it. Now to find those anomalies. Outside the utility closet, you hear footsteps and a voice. I'm not sure either, but now that so many people have chimneys, maybe he could sneak in that way. No, maybe he could, but now that so many people don't have chimneys, that's wrong. Another voice responds, actually, we've been working on a new kind of suit. Why is that bright? Is that also? No, there's no Easter egg in there. That would let him fit through tight spaces like that, but I heard that a few days ago they lost the prototype fabric, the design plans, everything. Nobody on the team can even seem to remember important details of the project. Wouldn't they have had enough fabric to fill several boxes in the warehouse? They'd be stored together, so the box IDs should be similar. Too bad it would take forever to search the warehouse for 2 similar box IDs. They walk too far away to hear anymore. Late at night, you sneak to the warehouse, who knows what kind of paradoxes you could cause if you were discovered, and use your fancy Wiz device to quickly scan every box and produce a list of the likely candidates, your puzzle input. To make sure you didn't miss any, you scan the likely candidate boxes again, counting the number that have an ID containing exactly 2 of any letter. and then separately counting those with exactly 3 of any letter. You can multiply those two counts together to get a rudimentary checksum and compare it to what your device predicts. For example, if you see the following box ID, A, B, C, D, E, F contains no letters that appear exactly 2 or 3 times. True. B, A, B, A, B, C contains 2 A's and 3 B's, so it counts for both. A, B, B, C, D, E contains 2 B's, but no letter appears exactly 3 times. True. A, B, C, 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 D contains 3 C's. A, B, C, D, D contains 2 A's and 2 D's. A, B, C, D, E, E contains 2 E's. And the last one contains 3 A's, 3 B's. Of these box IDs, 4 of them contain a letter which appears exactly twice, and 3 of them contain a letter which appears exactly 3 times. So 4 of them contain a letter which appears exactly twice, and 3 of them contains a letter which appears exactly 3 times. Multiplying these together produces a checksum of 4 times 3 times equals 12. So what is the checksum for your list of box IDs? So let's see. Let's see the input. Nice. Let's see. Oh, did I close it? So let's do code again. Input.text and main.go. Alright, so in input.text we're gonna stuff all of that, and main.go. Okay, so here basically what we need to do is find how many times each letter appears. Alright, so my question here is, for those that have, so this one, how many, but it only counts once. Okay, so it only counts once because there's 2 letters that appear twice. Yeah, okay, cool. So, okay, so let's start with the same thing as I did before, because I'm lazy. Wait, what? Oh. I'm just gonna remove all of these things, but this is gonna be pretty much the same thing, so I think this should be my, I'm gonna put it as skeleton.go. So we're gonna be using that later on. But okay, so what we need to do is for every word, so we're gonna be counting bar 2s and 3s. It's gonna be ints. And then for the word, it's gonna be as.text. And then we need to find whether there's letters that appear twice and whether there's letters that appear 3 times. So we can do, I can do counts equals a map of, let's do byte char. Char is not a thing, is it? No, byte to int. And simply count. So we're gonna do for, actually let's do it with runs. That's a better go way to do it. So we're gonna do, we're gonna iterate over the runes of the word, which now that I think we don't need to do like that, we can just do like this. And then counts of r++. And then, so, so if for key letter and count in range of counts, if C got 2, got 3, put your bulls. So if so if C equals 2, then got 2 equals true. If C equals 3, got 3 equals true. And if got2, then choose plus plus. If got threes plus plus. And then we're going to print choose plus times threes. Cool. This could be correct. Let's see. So I'm actually gonna try first with this input. So this input here, if we run this, go run main.go, prints 12. That looks pretty good. So let's go back to the previous value and 5,704. Yay! Okay, that was pretty easy. So yeah, so we just count how many times we find got 2, got 3, and that's it. I like that I'm not the only one going yay. Okay, so git add git commit -m. What should I do? Day 2 part 1, and let's create, and I'm gonna copy actually day 2 part 1 everything to, that's not what I wanted to do, part 1 everything to day 2 part 2, and then day 2 part 2 and code. I might consider actually trying to solve all of these problems also in another language. I'm considering Rust. So if you're interested in seeing that, maybe another day. Okay, so part 2. Confident that your list of box IDs is complete, you're ready to find the boxes full of prototype fabric. The boxes will have IDs which differ by exactly 1 character at the same position in both strings. For example, given the following boxes IDs, the IDs A, B, C, D, E, and A, X, C, Y, E are close, but they differ by 2 characters, this one and this one, the second and fourth, yes. However, the IDs F, J, H, I, J, and F, G, U, I, J differ by exactly 1 character, the third. This might be the correct boxes. What letters are common between the 2 correct box IDs? In the example above, this is fun by removing the different character from either ID producing F, G, I, G. Okay, cool. So, although it hasn't changed, you can still get the puzzle. We already have it, so that's cool. So we're gonna change. So what we need to do is, interesting. We need to find. I mean, there's many ways of doing this. Some of them smarter than others. But this is not a huge program, so I don't care that much about the performance. So what I'm going to do instead is, let me think about this. I could kind of hash it and compare the hashing, but that's not that interesting. I mean, I can compare 1 per each. Like, no, I don't care about performance, because like the only goal is to put the answer in there. I could do it by hand if I needed. Okay, so what we're gonna do, so let's go back to the empty thing. And so I'm going to do is I'm going to have to add, so words is gonna be our slice of strings, and words equals append words of s.text. Alright, so that is our beginning, and now we have all of the words. So let me open this one and change it to have only the ones here. Okay. So what we're going to do is this is a bad idea, I know, but I don't care. Word from word range on words, and yeah, there's an extra new line in the input file, but I don't really care about it because it will always be different to the rest. So even if I do that, like, it should not change the program, but yeah, true, I'll remove it. Okay, so let's do A and B instead of W and W, because that will not probably work. Okay, so let's check. It's red. Cool. Okay, so I'm just gonna continue a little bit more since the plumber is already gone. That was pretty quick. So yeah. So we were working on the day 2 part 1, which actually day 2 part 2. Yeah, day 2 part 2, where the goal is to find words that are exactly like almost the same except for one character. And I decided that I was gonna try to do it the easiest way possible, which is also not very, definitely not the most performant one, but I do not care that much. So that's gonna be by iterating over all of the words twice and finding the ones that are similar to each other. Actually, a quick, yeah, no, I don't care. I'm just gonna do it like that, because if I'm not mistaken, there should be only one. But they differ. So I wonder. So there should be 2 boxes that only have one character apart. So let's do if. So common and okay. If okay, print common and return. Otherwise, continue. And now we're gonna do the func compare of a b string that returns a string and a boolean. And so this is the part that is gonna be interesting. So what we need to do is for I range. So for how can we do it? I'm gonna do it character by character. So for I equals 0, I is more than length of A, I plus plus. If A of I equals B of I, continue. And if not, actually, yeah, so let's see, found diff equals false, else found if found diff equals true, so if found diff already, then return false, because we found 2 differences or more. Otherwise, found diff equals true. And so if we get here, we should also record which one is different. Oh, I know what I'm gonna do. So the index for the difference is gonna be -1 initially. So if the index is, 1 second, my phone is ringing again. Let me see, how can I do this? Okay, so as I was saying, instead of using that boolean, I'm gonna use an index. So if we already found an index and we continue and we find another one, then we should return false, because that is wrong. But if we arrive here, it means that we found. So if index is less than 0, then it means that that is a problem because found same word twice, which actually it's going to be something that's going to happen because we are iterating over this twice. So let's do this for I range of words and for j range of words like this. So that's going to compare only the word to the next ones. So we'll avoid doing this twice. I'm going to still keep these here for sanity. But then the next step would be the index should be, so the index, let's see, we should return a of something until I plus a of I plus 1 until the rest, and true. All right, and now here I'm gonna need to, index. Here for sure I'm gonna need some tests because I do not trust myself that much. So let's write a test, main test.go. That's gonna do package main func test compare t testing.t. And here we're gonna do is so we're gonna have some words. So tt is gonna be struct a b string, and this is gonna return a common string boolean and okay boolean. So this should be, so we have, let's use the ones from the example. So these two are definitely different. So these two are definitely different. So the comment should be this and should be false. But if we have something like this, so UE, that should return A, B, C, E and true. And let's do some where the word changes right at the end. So that's going to be A, B, C, D. And also right at the beginning. So that's going to be A, B, C, D, E. So that's going to be B, C, D, E. And one more. It's going to be, they have different sizes. So that should return false. And empty ones. So empty. So that should return false. And one more. Actually, we should say that these are equal. So is equal correct or not? Equal is probably not correct. So I'm just going to say if they're exactly equal, it's also return. Nah, actually, I think that these should be return A and true. Okay, so return A and true. Alright, so and now for tc range dt t dot run. So we're gonna call it this versus this, which is tc.a, tc.b, and the function which receives that testing.t. It's going to okay, so this function is going to say compare a and tc.a with tc.b, and that's going to return a common and okay. If tc.okay different to t to okay, then t fatal expected okay to be this, got this. So that's going to be expected tc okay and got okay. And if those are equal, then it's going to do if tc common different to c, t.fatal f, expected common to be this, we got this, which is tc.common and c. Alright, so let's run this test. And it doesn't work, so yeah, let's see why. Undefined A, undefined B. Oh, because it doesn't compile? That would be a problem indeed. Compare A and B. Oh, because these gonna be words of I. Bon dia. La pingbino. Words of J. And if, okay. What did it do? Oh, forgot that. See, okay, so let's run the test. Go test. Panic. That's not good. Any panicked? Test in the go. Panic. Compare. Func test compare. Test in the go. Wait, what is the line? It main the go 41. Interesting. How is this? Oh, because they're different sizes. Yeah, so actually, yeah. If len of A is different to len of B, then return false. That should make it go better. Okay, expect OK to be false, go true for A, B, C, D. How do you get true in there? So if A and B are equal, continue. If else index equals I. Okay, so that works a little bit better. A, B, C, D, E, A, B, C, U, E, expected OK to be true, got false. So let's see, let's print, so A, B, C, D, E, A, B, C, U, E. So the index can be, oh, wait, like this. Okay, that's better, that's closer. A, B, C, D, E versus A, B, C, D, E. They're equal, and we decided that those should be false. We agreed on that, because they're, actually no, we agreed that would be, no, that would be false, because we're comparing, it's only true when they differ by a single one. Okay, go test. Nope. A, B, C, D, E versus A, B, C, D, E. Oh no, so we want it to be false. Expected common to be got A, B, C, D. Oh yeah, so this should return just no. Cool, so now go run main.go. FGIJ, and according to the problem, FGIJ, FGIJ, cool. So that looks pretty good. So let's get all of this, put it in input.text, and run it again. And this is our output. And if we try that, perfect. Okay, I'm gonna do one more day and then I'm gonna stop. So let's see. Okay, so thank you. Okay, so day 3. Let's create the whole thing as before. Day 3, part 1. Oh, actually, nope. Advent of code, git add day 2, part 2, git commit day 2, part 2. Okay, and let's copy the skeleton to main.go and open this. Cool. And okay, so let's read day number 3. No matter how you slice it, the elves managed to locate the chimney squeeze prototype fabric for Santa's suit, thanks to someone who helpfully wrote its box IDs on the wall of the warehouse in the middle of the night, which that was us. Unfortunately, anomalies are still affecting them. Nobody can even agree on how to cut the fabric. The whole piece of fabric they're working on is a very large square, at least 1,000 inches on each side. Each elf has made a claim about which area of fabric would be ideal for Santa's suit. All claims have an ID and consist of a single rectangle with edges parallel to the edges of the fabric. All claims have an ID and consist of a single rectangle with edges parallel to the edges of the fabric. Okay. This sounds like a backpack problem coming up, I'm almost sure. Each claim's rectangles is defined as follows. The number of inches between the left edge of the fabric and the left edge of the rectangle. Okay? The number of inches between the top edge of the fabric and the top edge of the rectangle, the width of the rectangle in inches, and the height of the rectangle in inches. Cool. So it's basically just like it's a square, but a rectangle somewhere in a bigger rectangle. So a claim like 123 at 3254 means that claim ID 123 specifies a rectangle 3 inches from the left edge, 2 inches from the top edge, 5 inches wide, and 4 inches tall. Visually, it claims the square inches of fabric represented by pound sign and ignores the square inches of fabric represented by dot in the diagram below. Cool. So the problem is that many of the claims overlap, causing 2 or more claims to cover parts of the same areas. For example, consider the following claims. So 1 to 3, 4, 4, 3 to 1, 4, 4, 5 to 5, 2, 2. Visually, these claim the following areas. So 1, 2, and 3, and these ones are shared between 1 and 2, the x's. The 4 square inches marked with x are claimed at both 1 and 2. Claim 3, while adjacent to the others, does not overlap either of them. If the elves all proceed with their own plans, none of them will have enough fabric. How many square inches of fabric are within 2 or more claims? How many square inches of fabric are within 2 or more claims? What? So, if it also... Wait. How many square inches of fabrics... How many square inches of fabric are within 2 or more? I don't think I understand the question. The force. Oh, how many square inches of fabric are actually used by more than one claim? I think that's what it means. So in here, the output for this should be 4. Right? I think that's what the problem is about. If the elves will proceed with their own plan. Okay, so... Claim 3, the 4 square inches marked with x are claimed at both 1 and 2. Okay, so how many square inches of fabric are within 2 or more claims? Yeah, okay, so I think that's what it means. So here would be a 4. So let's use that as the input first. So input.text. And we're gonna read every single one of those. And we're going to, for every read, we're gonna do scanf of s.text, some format, and we're gonna use ID, x, y, width, and height. So var ID, x, y, all of those are integers. And if this returns an error, we should log fatal because we failed to read it. And I'm just going to print exactly the same. Oh wait, so that's gonna be person D, person D, person D, person D, person D. So, cool, so let's just print it for now to make sure that it is actually what I think it is. So D ID X Y H. All right, so if we print this, go run main.go, this should print. Let's do print like that, but that looks pretty good. Cool. So now the question is, how do we figure out whether they map or not? We don't know. We don't know how big the fabric is. The whole piece of fabric they're working on is a very large square, at least 1,000 inches on each side. At least, but we don't know how big it's going to be. So we will know only how big it is once we have the data. So 1 second, because someone's calling me again. Hello?
Hi. Okay. So, Paul let me know that Justin will be putting it on the key on top of the mailbox, and just to return it on top of the mailbox when you're done.
Oh, okay, great. Thank you.
Or return it to Justin, whichever. But yeah.
Yeah, and if you can leave it even inside of my mailbox if that's safer. But yeah, whatever. Okay, so do you know when? Huh?
Right now.
Sorry?
Now. You should be there now.
Oh, he should be there right now. Okay, so I'll go get it then.
Yeah.
Okay, cool. Thank you. Okay, so you see me again. Cool, everything is. Okay, so what I was wondering was, how do we do this? And I mean, we could do a map. We could try to get something like basically, gonna call fabric, which is a struct that has a map from struct. So let's say type coordinates is a struct xy int, and then do a map of coordinates to integers. So what we're gonna do is, let's see, actually now what I'm gonna do is I'm gonna keep it like that, because that way we can say, so function f fabric. Yeah, I'm back. My shower's still not working though, but I'm back. Okay, so fabric, we're gonna do add claim, and that claim is gonna get the claim ID, which is an integer, the x, y, all of that, int, and that's it. You're not gonna do anything else. Can you do a map of array of integers? Yes, you can, but I find that incredibly ugly, so I will not do that. I like the fact that now I can do, from here I can do m of, actually I'm gonna call this xy, because I'm gonna be using that pretty often. Cool, so yeah, so at claim, we're gonna do is if m equals nil, so if f dot m equals nil, we're gonna set it up. So f dot m equals make map of xy int. Otherwise, we would do for I equals x, so I smaller than wi plus plus, for j equals 0, j less than h j plus plus, f dot m of x y of x plus I j plus dot y, y plus I equal plus plus. Okay, so that should work. A slice is not comparable. Slices are not comparable, but arrays are. So that would still work. I just don't like it from a static point of view. But I think it should still work. So if you do this, that should not compile because it's a syntax. Oh wait, that should not compile because I'm silly. But yeah, invalid map key. But if you do a 2 there, that's still valid because that is actually correct. So, but XY, I just like XY better because we can do this thing. I like it better. I think maybe it's me being weird, but it just feels better. Okay, so we're going to do, so for every single one of them, so we're gonna set up fabric, and then we're gonna do f dot add claim of ID X, Y, or U, H. And what are you complaining about? F redefine. Oh, let's call it fabric then, because we're not going to be using the type name anymore. So fabric at claim. And it takes more lines of code, but no more memory. Yeah, it doesn't take more memory for sure. And it takes like basically one more line of code. So come on. I mean, also another option would be to use the struct definition really here, but then this would be much uglier. So I'm just going to keep it like that. Okay, so we added all of the claims. And then at the end, we're going to do println fabric measure badly claimed, I'm gonna call it, and that's gonna be a function fabric badly claimed that's gonna return an integer. And what this is going to do is gonna go point by point that we've set up and find whether it's true or more, and then just add those. So count equals 0 for xy equals, actually let's call it pos. Is pos a better name? Okay, p, range of f dot m. So we're gonna iterate, this is a map, so we're gonna ignore all the keys and just ignore over go over the values. So if p is more than 1, then count plus plus and return count. Cool, so let's see. Go rum in the go. Then, that seems wrong, right? Okay, so what I'm gonna do now is and this is why I like having a type, is that we should be able to print this. So how would you print this? I'm gonna find for key for position. So this should be C for count actually. So for position range f dot m, min x, min y are so min max x, max y. Actually, we can also, I'm just gonna do the maxes. Those are integers. If p dot x is more than max x, then max x equals p dot x. If p dot y is more than max y equals p dot y. And then we are going to go for x all around, for y. Wait. Let's do this. Is gonna be, this one is gonna be x, and this is gonna be y. and we're gonna print f.m of x, y of x, y, println, and I don't care. Let's just call it print, and just print directly to the output. Type integer as type string in wait, what? Cannot use literal type integer as type string. Oh, printf. I meant print. And let's call these as we are doing every claim. So after every claim, we're gonna print fabric.print. And probably one more. All right, so that's wrong. 4? Wait, what? That is totally wrong. That is very, very wrong. What did I do? So x plus I, y plus j. Okay, so that is 1. That is, now there's 2 because that area is in between the two of them, and then we add this one. So that's not much what we saw on the example. So 4. Okay, so also the width is actually less of equal. Off by 1, yeah. Okay, so that is 1, this is the other one, and this still doesn't match. So this 4 by 1, 2, 3, 4, which is what we read here, right? Yeah. And it starts at 1, 1, 2, 3, 1, 2, 3, and 1. So 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 1. 1, 2, 3, 4, 5. What? Wait. Let me do a clean because I think I'm not in the right place. One, two, three, four, 5. 1, 2, 3, 4. There's something wrong in there too. Let's see. What did I do wrong? That is at claim x plus I, y plus j, and j goes j plus plus. I'd say this looks good. Yeah, array coordinates are 0 based. Yeah. Because it's a distance, so 0 is the first one. Yeah. But that is correct. Switch x, y and x imprint. I mean, technically that doesn't matter, but no, that doesn't matter because the thing is that this is actually fine. It's 1, 2, 3, and 1 up. But 1, 2, 3, 4, 5, and 1, 2, 3, 4. 1, 2, 3, 4, 5. There's a bug somewhere. Max y. This looks good. I don't think the printing is the problem. I think that the problem is the at claim. Did I read the thing incorrectly? Let me do printf adding claim ID So ID X, Y, W, H. So we're adding 1, 3, 4, 4. So 1, 2, 3, 4. But how is it that if both are 4, why do I do 4 here, but 1, 2, 3, 4, 5 here? So I is correct. This one is somehow not correct. J plus plus X plus I, Y plus J. I'm losing my mind. Where do I use one less than and the other one I use less or equal than? Because that would be the mistake, but I don't see that anywhere. Oh, and maybe... Yeah, this should go actually one more. Oh, I know what that is. This so stupid. So the problem is that I fixed that bug in the printing by modifying the claim, and that was wrong. Okay, so that is gonna be okay now. 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, and then okay, and that returns 4. Cool. So that looks good. I see. Printing stuff is actually very useful. So let's run it with the actual input. Thank you. Okay, so the input is going to be all of this, and this is going to return. Nope. Too much printing. Let's not print this, and also let's not print the fabric here. Okay. And that is the number we get. Whoa, that's bright. And submit. Yay, we got it. Okay, so one more and then I go, because I want to go out tonight. Okay, so git add, git status, git commit, day 3 part 1. Okay, and let's do one more. So I'm gonna copy part 3, day 3 part into part 2. That's 3 part 2. Open with Visual Studio Code again. Okay, so let's read the part 2. Amidst the chaos, you notice that exactly one claim doesn't overlap by even a single square inch of fabric with any other claim. If you can somehow draw attention to it, maybe the elves will be able to make Santa suit after all. For example, if in the claims above, only claim 3 is intact after all claims are made. What is the ID of the only claim that doesn't overlap? Ooh. Okay, so that means that now we actually need to remember what claim it is. And okay, so we're gonna keep track of the ones that are somewhere. So we're gonna change the fabric to be actually a slice of ints. And we're gonna keep track of the IDs in there. So that's gonna be slice of ints. That's gonna be, so here we're gonna do is do equals append, let me do p equals that thing, and then do p f dot m of p, and let's add the ID. And then if, so now this is going to be length of C instead. So it's going to be IDs. So that still works. So this should still print the same result. Let's try that first. 10,000, that's 100, 1001, 906. Okay, cool. So we still have the same results. That's good. Because what I've changed doesn't really break the previous code. Now what I'm going to do though is on the badly claim, so here we're gonna print the length too, because otherwise the printing is gonna be broken. But here what we're gonna be counting is, so we're gonna do func f fabric, not badly claimed, but there's gonna be safe option, and that's gonna be the integer of the claim. So what we're gonna do is similar to this. So actually no, we're gonna go for pl range f dot m. So for the position and the list of IDs, let's call it IDs. I like it better. IDs in the map. If len of IDs. So let's say bad equals. Okay, so I'm gonna get first all of the IDs that we've seen ever. Actually gonna store that also here. So ID is gonna be slice of integers. And every single time we add a claim, we're gonna do f.ids equals append f of IDs of ID. So that way we're gonna have a list of all of the IDs. Should I do that or should I? Let's do a set. Normally, for sets, I normally do this. It's a map of something to booleans. Go doesn't have sets, so instead you do that, and it works pretty easy too. So then we're gonna do f.ids of ID equals true, basically marking it as seen. So now that we have this, we can go back to the safe option and say that we are going to go and can I clone a map? I don't think I've ever done that. For ID, range IDs, good equals map of int bool. Okay, so actually since what I want to do is I want to clone it, there's not going to be a map. I'm going to go back to the slice of integers that we had before, and that's going to be f of IDs equal append f.ids of ID. And then here we're going to create a map. We're going to go over all of the IDs. We're going to set good to good of ID equals true. So now we have a list of all of the ones that are good. And then, so we're gonna go here, and for every position, we actually don't care about the position, but if the len of IDs is larger than 1, then that means that all of the claims that are in there are wrong. So we're going to go for, so let's do it the other way around. If these 1 or less, then continue, because that doesn't mean this is bad. But if any of these are bad, we're gonna go for ID range of IDs. We're gonna do good delete good of ID. And then we should only have 1. So if length of ID of good is bigger than 1, it's actually different than 1. Let's do log fatal. Unexpected amount of goodness. And that's gonna be our good, length of good. Otherwise, we need to get the first result in the map. Why is this complaining? Map in bool, that is. Okay. So how do we get the first one? I'm gonna do ID range good return ID. It's kind of an ugly thing to do, I feel like, but why are you complaining? So ID good return ID. Panic, YOLO, and let's use puking face. There you go. I think that explains pretty much what happens if we get there. Okay, so now we need to change the program to, instead of calling badly claim, it's going to print safe option. An expected amount of goodness is 2, so we got 2 different ones that are actually good. Let's use it with the small data set first. So 0. That seems wrong too. Let's see. So when we have the claim, we remember the claim, which is good. Let's print the claims at the beginning of safe option. f.ids. Should print 1, 2, 3. Okay, cool. So that is correct. Resetting them to true. Let's print the good every single time we iterate here. So I'm actually going to do it here. So removing claim. So claim is not safe. Printf. That is ID. And let's print the new status of good. Let's start also by printing good once it's ready. So we start with 0, 1, and 2 are. Oh, that's dumb. Oh, I know. That's so dumb. So the problem is that I am iterating over the positions, not the IDs. So that's why. That's pretty dumb. Okay, so let's see that now. Alright, so now we have 1, 2, 3. We remove 1 because it's not safe. We remove 2 because it's not safe. And that gives me the idea that once, so if len of good equals 1, we should just break. Because then we know we're done. So there's no point in continuing. That way the output is much shorter, which is good. Cool. So now that we have this, let's remove all the extra printing, which is not necessary. And 3. Cool. And the output for the big data set is 243. And this is correct. Yay. Okay, so that was fun. Let's save that too. Day 3, part 2. So yeah, I'm basically done. So I guess that we have some time to answer any questions if anyone has doubts about this code. I think it's pretty straightforward. It's kind of a weird piece of code, but it's also kind of a weird program, I guess. But that's pretty much it. Thank you. How's that vein of code going? For me, it's going great. I wonder how it's going for Chris, because he's also doing it on his own channel. But yeah, so far this was pretty fun. It's hard enough that it's challenging, but easy enough that I'm able to make it while I'm talking to people. Because otherwise, I don't think I would be doing this online. I would be doing it hiding somewhere instead. So thank you. This is really good idea to create this advent of code. They get harder. Oh, interesting. Okay. Well, I have to continue another day. I was able to do 3 days in like an hour and a half, so that's great. Oh no, I'm actually looking forward for the hard ones for sure. Cool. Okay, so I will put all of this. I will add a little bit of documentation on the README and stuff, and I will push it to that's gonna be here. So this is gonna be the URL: github.com/campoy/adventofcode2018. Yeah, there was an emoji for the panic. Because if actually maybe is there a better way to return the first element in a map? I don't think so, right? Like it is sad, but this is how you need to do it. Because I don't know the key either. The Go source code at some point has first, it's the only one. So the set only has one element. So I want to return that single element. So I did it like this. It feels a little bit weird, but it works. That's why I have that panic yellow puking. Yeah, I'm not super happy with it, to be honest. But yeah, I guess that the other option would be to do something like var save id int, and then do id equal so save id equals id, and then return save id. Return only element in the set. I guess this is less fun but more normal code, so I'll keep it like this. I don't know any Perl, and I'm okay with that. So yeah. Cool. Okay, so yeah, I'll be pushing this in a minute to my GitHub under Advent of Code 2018. So if you want to check it out, and if you have any comments or questions on the code, you can just do it there. This looks less safe if you care about not returning 0 if the set is malformed. I do check that there's only one element right before, so that should be okay. This will log fatal if this is wrong, so should be fine. Don't you think? I think this is fine. Cool. All right, so yeah, I'll be pushing all my code there, and have a great weekend, y'all. See ya.